Hey there everybody, you've made it to the final factoring video. Congratulations. All your hard work, everything is going to pay off at the end of this. Keep it up, you got one more. What we're going to learn how to do in this one is to learn how to factor what's called a quadratic trinomial. Those are words you should recognize from an earlier quiz cycle. Quadratic just means it's going to be of degree 2. Here we have our polynomial written in standard form. That one right there is our term with the highest degree, and it is of degree 2, meaning it's quadratic, and it's a trinomial, and it's got 3 terms. If we cut it off in between the plus or minus signs, we see there's 1 term, 2 terms, 3 terms. So a quadratic trinomial, and we're going to factor this by what's called grouping, which you might say, hey, wait a minute, isn't that what we just did? Yes it is. But here's the catch. This quadratic trinomial can't be grouped because it doesn't have 4 terms. So something's got to give there. Anytime you see this, the quadratic trinomial, know that you're going to need to pull out this technique that we talk about right here. So first of all, this can't be factored using what we know. Everything we have already is simply not going to work. Let's look at what happens if we try and use the greatest common factor. We would first need to factor every term, and then we would look for what they have in common. Well, they don't all have a 2, they don't all have an x. There is nothing these guys have in common. So a greatest common factor, not going to help me. I gotta find something else to do about that. So maybe I can try grouping. So I group the first 2 together, and then I group the it has 3 terms. We need an even number of terms in order to do grouping. So grouping's not going to work. So what's a guy to do? One of the most powerful ideas in mathematics, maybe the most powerful idea in mathematics, is to take a problem that you don't know how to solve and turn it into one that you do know how to solve. So right now, as it stands, 2x squared plus 7x plus 3 is a puzzle that I simply can't solve. I have no technique that will allow me to do that. But let me change something here. What if instead I wrote 2x squared plus 1x plus 6x plus 3? These two are exactly the same because if you look, 1x plus 6x is still going to be 7x. The 2x squared didn't change, the 3x, or the 3 at the end didn't change. All that changed was I took that 7x and I split it into 2 parts. And something kind of magical happens here. If I try this, now this has 4 terms. Factoring by grouping is on the table. Let's see what happens here. First I factor my first set, and look, they do have something in common. Recall that when you use up all the factors in there, you put a 1. Maybe, well, I don't know, let's just try it. Let's see what happens with our second set. They have something in common. And wow, check that out. These are the same, which means my grouping is successful. I'll write my answer up here. I take the parts in front, x, and a positive 3 times 2x plus 1, and now I've factored that trinomial by grouping. And notice all I did was split that middle term into 2 parts. Now before you get too excited, those 2 parts that I split it into have to be very specific. So in order to turn a trinomial into a 4-term polynomial that I can factor by grouping, I have to split the middle term into 2 terms that will multiply together to be equal to a times c and add up to b. Then I can factor by grouping. And I can hear you ask, or I hope you're asking because it means you're paying attention, oh, what the heck are a, c, and b? So it kind of looks like this. Any quadratic trinomial I can write in a form that looks like this. A is the coefficient of the squared term, B is the coefficient of the linear term, and C is the constant. But you can't guess why we call it C. Anyway, whatever my terms are, when I split this up, I'm going to have ax squared plus some number x plus some number x, and it could be minus if this is negative, but for now we'll just generalize, plus c. So whatever these two numbers are right here, when I multiply this times this, I have to get the same thing as a times c. And when I add this and this, kind of obviously it has to add up to b, or otherwise this thing doesn't split up properly. So my hardest part of this is that I need to find numbers to put here and here, that when I multiply these two numbers, I get a times c, and when I add them up, I get b. And that's what we're going to learn how to do, is the process, the technique for reliably finding those numbers. So I'll start looking at some examples. As we've seen in the past, I'm going to have my example, and then I want you to be working your example at the same time, step by step. You're trying to mimic what I'm doing with your expression. So I'm going to work this one, and you work that one at the same time. So let's start by writing it down. Seems obvious, doesn't it? And then what I want you to do is I want you to identify A, B, and C. A is the coefficient of x squared, 5 in this case. B is the coefficient of x to the first power, the linear term, so 32, and C is 35. Don't just rely on their location, because if this isn't in standard form, you may have to go hunt for it. Yet another reason to write it in standard form. Always write it in standard form. Now that I have A, B, and C, I want to split this thing up into two pieces where B is broken down into numbers that multiply together to give whatever A times C is and add up to B. So I'm going to create a chart right over here. And in this chart, on this side, I'm going to put A times C. So I do 5 times 35, and that's going to be 175. And then on this side, I put B, which is 32. So now what I need are all the numbers that'll multiply together to give 175, all the factors of 175, and I need to see which of those factors add up to 32. And as you may have guessed, your calculator is going to be remarkably handy. So let's go ahead and have that fella pulled up because we will most definitely want it. And so what we're going to do now is we're going to go through and list all the factors of 175. Now it could be, it starts with 1. Always include that. 1 times 175. Now I don't want the prime factorization here. I just want any old factorization. So I'm going to start this by just trying to divide by 2. And that gives me a decimal answer, so that's not good. So let's take 175 and let's divide it by 3. That's no good. 175 and divide by 4. Notice I'm not going through the primes. I'm going through every single stinking number. That doesn't work, so I do 175 divided by 5. And that one does work. 5 and 35. So I would write down 5 times 35. And now I just keep trying until I get them all. And I'll show you how to know you've gotten them all. Let's do 175 divided by 6. No luck. 175 divided by 7. And hey, look at that. 7 times 25. So I will put that one there. And we just keep going. And now seems like a really good time to kind of tell you where we're going with this as far as how we know we can stop. I divided by 7 and I got 25. When I get to the point where this number is bigger than this number, then I'm ready to stop. But not until I get to that point. So let's keep trying. 175 divided by 8. Nope, doesn't work. 175 divided by 9. All right, notice that's 9 and 19. We're getting close to them passing each other. So divided by 10 is going to be 17.5. Doesn't work. You get the pattern that this might be kind of boring sometimes. All right, 11 and 15. Now they're getting really close. 175 divided by 12. 175 divided by 13. Oh, and notice they're almost the same. And now let's do 175 divided by 14. And when we do this, notice now 14 is bigger than 12 and a half. I can stop. I've got them all. This is it. That's all I got to work with. So now my job is to look through these and to find which ones add up to 32. So 1 plus 175 is 176. 5 plus 35 is 40. And you saw this coming. 7 plus 25 is 32. So these numbers right here are the ones that I'm interested in. And these two numbers right here are what I'm going to split my b part into. So it's 5x squared, and now I have these two numbers plus 7x plus 25x, and then the 35 just hangs out on its own. And now, once I'm here to this point, all I do is factor by grouping, just like I did in the previous video. Now that I'm at this point, I can combine them, and I will write the answer down in red right here. So I would take what I have in front, x, and a positive 5 times 5x plus 7. Notice, just like when we did grouping, these had to be the same. And there you go. I have now taken this quadratic trinomial, turned it into a 4-term polynomial, and then factored that by grouping. So now what we're going to do is we're going to take a look at yours, and let's make sure that we did this correctly. Hopefully that went well for you. Let's try another one, but now you'll notice that this one is kind of lousy with negative signs, and that does really have an impact on what we're doing. So let's start by writing it down, and of course finding A, B, and C. Notice that that negative sign comes with it. A is negative 6, B is negative 11, and C is negative 5. And I do have to account for that as I'm finding these values. So now let's take A times C is negative 6 times negative 5, which is 30. And B is going to be negative 11. Now I have to find all the factors of 30 that will add up to negative 11. So I start with 1 divided by 30, which is that. 2 divided by 30 is 15. 3 divided by 30 is 10. 4 does not go in evenly. 5 does, as 5 times 6. And 6 does not, as 5 in a decimal. So I know to stop there because now the numbers are reversed. And so what I can see here is if I add these up, 1 plus 30 is 31, 2 plus 15 is 17, that's 13, and that's 11. Very clearly, none of those add up to negative 11. And the reason is we missed some factors. So it's not just 1 times 30 that'll add up to 30. It's also negative 1 times negative 30. A negative times a negative is a positive. Or I can do negative 2, pardon my stray mark there, times negative 15, or negative 3 times negative 10, or negative 5 times negative 6. And when we add these up, what you'll notice, negative 1 and negative 30 add up to negative 31, just the opposite of what we had there. Negative 2 times negative 15. If I add those instead of multiply, I get negative 17. And you can see this is negative 13. And this one right down here is negative 11. So what I'll do is I'll now split that middle term into minus 5x and minus 6x. Notice that if I do negative 5 minus 6, I still get negative 11. And now I can factor by grouping. And notice when I factored this that I took out a negative with that. That's going to be very important. All right, let's try the other set. I can see that I end up with the same term, or the same polynomial twice, so that's a good sign. Now all I have to do is put it together, and notice how those negative signs came out. If I don't take care of those negative signs when I factor, I'm going to end up with some ugly situations. Easier to take care of them while I'm doing the grouping part. And there is the solution. So now, let's see how yours went. Now we can take a look at another one, and what we're going to see is, frankly, another kind of funny situation. So let's take a look at it just as with any other. Let's start by writing it down. So negative 3r squared plus 5r minus 2. Identify a, b, and c. And now let's try and find our factors. All right, so far so good. No problems. This was actually even a little bit simple. So now what we need to do is rewrite it. And so far everything seems like it's going pretty normal, and frankly it is. Plus 2r plus 3r. Don't lose this variable right here when you write these down. A lot of people do that. Minus 2, and then we go to do our grouping. And let's just do that like we know how to do. Hopefully this is getting to be old hand. And do the other one. There's nothing in common here, so when that happens, I'm just going to write a 1. And there we go. I factored by grouping, except that I haven't. Do you remember that situation where I have the same numbers, but the signs are backwards? Here I have negative 3r, and here I have positive 3r. Here I have positive 2, here I have negative 2. So when this happens, what I have to do is factor out a negative 1. I usually choose to do that from the second one. However, the choice is yours. You can do it to either set. So what I'm going to do is make the number on the outside negative, and that changes the sign of everything on the inside. So what was positive becomes negative, what was negative becomes positive. Now my sides match. And I can, as usual with grouping, write the parts that are out front, now a minus 1, and the parts that were similar on the inside. And I haven't been saying this, but this is very true. You can go back and check your work on any of these by going ahead and multiplying these binomials through. You're always able to check your work on this, which is actually kind of nice. All right, let's check yours and make sure everything's copacetic. And now for our final example, what can happen as far as just making things, I don't want to say as bad as possible, but we can check this out. There's something we've been neglecting, something I ask you to do every single time before we did grouping, and it turns out here it rears its ugly head. If I write this down, 15k squared minus 25k plus 10, you might have a feeling that there's a 5 involved with all of these. So it turns out that I can actually factor out a greatest common factor before I even start doing anything else. So let's go ahead and take a look at that. And so what happens is there's a 5 that I can factor out on all of this, but it still leaves me with this quadratic trinomial, and so now I've put that 5 on the outside, but I still have to try and factor this. And so I'll find, just as before, A is now 3, B is negative 5, and C is 2. Now you will be able to still factor this if you left it as 15 and negative 25 and 10. But notice that when I do A times B, if I don't factor out that greatest common factor first, I'm going to end up with 15 times 10, or 150, that's right here that I have to deal with, instead of 6, which is noticeably easier to deal with. So if you don't factor that out first, you're just going to end up with bigger numbers to deal with. Everything will still work out. You'll just end up having to deal with larger numbers than you're used to, and you'll still need to factor that out at the end. So here I've got negative 5. My factors of 6 are 1 times 6 and 2 times 3. That adds up to 7 and 5. None of those are negative though, so I have to consider that it could be that situation as well, which would add up to negative 7 and negative 5. And remember, if this number was negative, one of these guys or one of these guys would have to be negative, and so I would have to consider both possibilities. Meanwhile, though, this fits our bill right here for exactly what we want. And notice this 5's got to travel with us when we split this thing up. 3x squared, or k squared rather, minus 2k minus 3k plus 2. And now I factor by grouping inside the parentheses. And notice I've got my situation where things are backwards. I've got a 3x there and a negative 3x there. So I'm going to change the signs. This would now be a plus 3x. And this would now be, or k, excuse me, and this would now be a minus 2. And so now I'm ready to rewrite this, and I'm so out of room, but I'm just going to write this down here in red. I have 5, and then my front terms, k minus 1, and then my whole second polynomial, 3k minus 2. And now I have factored that with having to pull a greatest common factor out. So be aware that that is an option. Let's check out yours and see how it went. And there you have it. That is everything we're going to do with factoring. You made it. I know that is super exciting. So here we go. This is to summarize everything with factoring. If you've got a monomial, find the prime factorization of the coefficient, rewrite the variables with exponents as multiplication. You can factor any size polynomial by finding a greatest common factor. Factor each individual term, find what they all have in common, and you pull that piece called the greatest common factor out as the front part of a distributive property problem. If you got a 4-term polynomial, group it. Take the first 2 terms, factor for a greatest common factor. Take the second 2, greatest common factor, rewrite it as polynomial multiplication. And then if you got a quadratic trinomial, I know this says binomial, it's supposed to say trinomial, split the middle term into two terms that will multiply together to be a times c, and add up to b, and then you factor by grouping. Turn it into a problem that you know how to do. All right, guys, it's a ton of stuff, but you're impressive people. You're smart, you're powerful, you're capable. I know you can do this. Practice hard and best of luck.